So a certain test for mono has a 99% chance of correctly diagnosing a patient with mono and a 5% chance of misdiagnosing a patient who does not have the infection. So suppose the test is given to a group where 1% of the people have mono. If a randomly selected patient's test result is positive, what is the probability that he or she has mono? So I am drawing a two-way frequency table for this to kind of help me through this. And so what we're going to do here is we are going to just select a random number of people. I'm not going to do 100, but we do want to select a number of people in the multiple of 10s. It's just an easier number to work with. So 100, 1,000, 10,000, it's up to you. I'm going to choose 10,000 people. So let's just imagine that we tested 10,000 people. All right. Well, out of those 10,000 people, let's say that 100 of them have mono. Okay, so 99% of the time, if a person has mono, the test will come out to be positive. That's what it means by it having a 99% chance of correctly diagnosing a patient with mono. So out of 100 people, 99% out of 100 people is 99. So that means the number of people in this category that have mono and would test negative. If I do 100 minus 99, that's just one person. Okay. So I told you I randomly picked 10,000 people. Again, we want to do in multiples of 10. So 100, 1,000, 10,000. I chose 10,000. That's just what I chose. And so if I do 10,000 people minus 100, that leaves me with 9,900 people left in the study. Okay. So now it's saying that there's a 5% chance of misdiagnosing a patient who does not have the infection. So this person does not have mono, but they're going to test positive. That's the misdiagnosis. They don't have mono, but they're testing positive. There's a 5% chance that that would happen. So 5% of 9,900 people is 495 people. Which means that out of the 9,900 people left, which I could write here, 9,900 people minus the 495 people that I have in this category of not having mono would leave me with 9,405 people who don't have mono and they correctly test as negative. Okay, so now I'm going to add up the column totals. So 99 plus 495 is going to give me a 594. And 1 plus 9,405 is going to give me a 9,406 people. And then altogether, remember I told you that we were randomly testing 10,000 people. You could have chosen a different number, but it's easier to work in multiples of 10s. All right, so the question is, right, if a patient or if a randomly selected patient's test result is positive, so we're testing positive, okay, how many of those positive test results would the patient actually have mono? So out of all the positive test results, how many actually do have mono? So out of 594 people, 99 of those people have mono. So it would be 99 out of 594, which comes out to be about, we're going to round to 17%. All right. So that is what the process that we could go through to do this type of problem. But writing a two-way frequency table is best for this. I'm not going to have you guys explain. I actually needed to take that out. All right, just going through this process alone was a tough process. So 17% is the correct answer. All right, moving on to number 2. So Kayla asked 20 students in her class whether they owned a cell phone or a laptop or both. So automatically I can put on, and I apologize, I don't know why I don't have this category in here. Because there should be a total category here too. In yours I have it, but in mine I don't. All right, so all together, she surveyed 20 students, so we can automatically fill in that cell there. 60% of the students said that they own a cell phone. So if I find 60% of 20, which is just 0.6 times 20, and how I found the 0.6 was to convert the percentage into a decimal, I'm going to divide by 100. I wind up with 12 students owning a cell phone. So in the cell phone column, there's 12 students. 30% of students own a laptop. So 30% converted into a decimal is 0.3, and if I multiply that by the 20 students that she surveyed, I would wind up with 6 students. So 6 of the students owned a laptop, so that's this right here. And then it says 10% of the students owned both a cell phone and a laptop. So 10% written as a decimal is 0.1. And then times 20 students, I wind up with 2 students owned a cell phone and a laptop. Now we are going to complete the rest of this two-way frequency table. And in the laptop row, I have a total of 6 students. And if I do 6 minus the 2 students that have a cell phone, I wind up with 4 students do not own a cell phone, but own a laptop. And out of the cell phone total, I have 12 students. 12 students minus the 2 students that own a cell phone and a laptop bring us to 10 students who own a cell phone but no laptop. And then, in the complete total of the row, I have 20 students total, and in the cell phone column, I have 12 students altogether. So 20 minus 12 gives you 8 students do not own a cell phone. Well, if 8 students don't own a cell phone, 4 of those students don't own, or 4 of those students own a laptop. 8 minus 4 gives us that 4 students also do not own a laptop in that category. And then in the no laptop row, 10 plus 4 leaves us with 14 students total in that row. So now I just finished the two-way frequency table. All right, that brings us to the end of the level 4 lesson.